Hello students, now we are going to continue our chapter real numbers. In previous class, we discussed how to prove square root 2 is a rational number. Now, today we are going to study whenever a rational number is terminating and non-terminating. For this, in your book, 3 theorems is given. Theorem 1.5, Theorem 1.6 and Theorem 1.7. We are going to study them. In Theorem 1.5, it is given that let x be a rational number whose decimal expansion terminates, then x can be expressed in the form P upon Q, where P and Q are co-prime, and the prime factorization of Q is of the form 2 to the power n, 5 to the power m, where n and m are non-negative integers. First of all, the number x is a rational number and it is in the form of P upon Q, such that the value of P and Q are co-prime, means the GCD of P and Q are 1, right? Now we have to prove that, and we have to show that if it is terminating, if it is terminated rational number, so the denominator is in the form of 2 to the power n and 5 to the power m. Now let us see one example. 23 divided by 100. Now 23 divided by 100, both are co-prime number. It is also a rational number, and that means it is in the form of P upon Q, where the GCD of both is 1, so it is co-prime. Okay, now first we see it is terminated or not. So whenever we divide 23 by 100, the answer will become 0.23. 0.23 means it is terminated, no expansion is there. Okay, now if it is terminated, so in our theorem it is clearly stated that the prime factorization of Q is in the form of 2 to the power n and 5 to the power m. So we try to factorize 100 to, it will become 50 divided by 2, so answer is 50. Now again divided by 2, so our answer is 25. Now it is not divisible by 2, it is divisible by 5, so 5 again, it is also divisible by 5, so we will get 5 again. Now we can write 100 is equals to 2 into 2 into 5 into 5, that means 2 to the power 2 into 5 to the power 2. So it means we can write 100 is equals to 2 to the power 2 into 5 to the power 2, where n is equals to 2 and m is equals to 2. Both are non-negative. Non-negative means all the positive integers and 0 also included in it. So the value of n and m is 2 or 2. So we can write denominator in the form of, in the prime factorization of 2 to the power 2 or 2 to the power or 5 to the power something. So that means we can able to write 100. Here we see that whenever a number is terminating. That means whenever a rational number is terminated, we can write every rational number, every denominator of rational number in the form of this. Whenever a rational number is terminated, we are able to write our denominator like this. And its converse is also true. Whenever we are able to write the denominator of a rational number in the form of 2 to the power n or 5 to the power m, so definitely that rational number is terminated. And the converse of 1.5 is 1.6. Now let us see theorem 1.6. Let x is equals to p by q be a rational number such that the prime factorization of q is of the form of 2 to the power n and 5 to the power m, where m and n are non-negative integers. Then x has a decimal expansion which terminate. Now here it is given that a rational number in the form of p by q, or q is in the form of 2 to the power n and 5 to the power m. Now we take our denominator like 2 to the power m, n and 5 to the power m. We take our numerator like 12. Okay. Now, so it will be terminated or not? 12 divided by 2 to the power 2 matlab 4 and 2 5. So 12 by 20. So our rational number is 12 by 20. Now we see that it is terminated or not. So it is terminating. So it is clear, whenever we are able to write a denominator in the form of 5 to the power m or 2 to the power n, so it is terminated. Definitely that rational number is terminated. If rational number is terminated, so we can write denominator in the form of 5 to the power m or 2 to the power n. Both are true. So converse of 1.5 is 1.6. Now let us see our theorem 1.7. Theorem 1.7. Let x is equals to p by q be a rational number such that the prime factorization of q is not of the form 2 to the power n, 5 to the power m, where n, m are non-negative integers. Then x has a decimal expansion which is non-terminating. Then now let us see an example. We put 10 by 3. Okay. Now 3 is not in the form of 2 to the power or 5 to the power, but it is a rational number. We can write it in the form of p by q. Now let us see. It is also can we write 3 3 3 3. It is non-terminating but repeating. Okay, non-terminating but repeating. So it is a rational number which is non-terminating, repeating, and we can write like this. So whenever we are not able to write denominator in the form of 2 to the power something and m to the power something, so that rational number is non-terminating, repeating. If number is not non-terminating or non-repeating, so that is not a rational number, so not a point of discussion. It is definitely irrational number. So today we covered theorem 1.5, in which if number is terminated, then we can write denominator in the form of 2 to the power n or 5 to the power m. In next theorem, if the denominator is in the form of 2 to the power n and 5 to the power m, so definitely that rational number is terminated. And next, if we are not able to write denominator in the form of 2 to the power n or 5 to the power m, so that rational number is non-terminating and repeating. Here we are discussing about rational number, not irrational number, because the clear definition of rational number is non-terminating, non-repeating. Now let us see an example of your book 17/8. It is a rational number. Okay, so which type of this rational number? So we try to write denominator. We try to factorize, prime factorize of denominator. We know that prime factorization of 8 is 2 into 2 into 2. That means 2 to the power 3. So we can write denominator in the form of 2 to the power 3. So it is a terminating rational number. It is a terminating rational number. Now we check in a question number 2 in your book, it is asked to check if rational number, you are saying that it is terminating, then check it. So now we check it. 17 divided by 8. 17. 8 2s are 16. 1 is remaining. We take point in a decimal, so 0 is here. Now 8 1s are 8, 2 is remaining. Now we put again a 0, so 8 2s are 16, 4 is remaining. Now again 0, 8 5s are 40. Now nothing is remaining, so our division is 2.125. It is terminating. 2.125. So here we say that if the rational number is like this, and we can write her denominator in the form of 2 to the power or 5 to the power, so it is definitely terminated. Let us, in this way you can solve your full exercise 1.4, and your chapter real number is finished now. If any doubt, you can comment. If you like these videos, then please tell me. I will make another video of next chapters. Thank you.